Good morning, everybody. My name's Pete Thompson. I'm the manager, or the Aquatic Services Manager for Invercargill City Council, and I'm based at Splash Palace. I think before I begin, it's important just for me to let you know that I did try to delegate this task to one of our maintenance guys, but he told me he was going to be sick today. So please, I will try to answer your questions if you have any, but if we could just perhaps lay off some of the really heavy technical stuff. So I guess today I'll be talking to you about our experiences with the conversion from coal to wood fuel. Although conversion probably isn't the right word. It's more about the change from coal to wood fuel. I'll cover off how the decision was made, some of the challenges and thinking around this, the change itself, and the outcomes to date, including sort of a high-level overview of the operational cost and effect on our bottom line. I'm actually just going to skip through some of these slides. So Splash Palace was built in 1996. It has a range of different pools, a 50-metre Olympic pool, wave pool, tots pool, spa pool, sauna, hydroslide, cafe, multi-purpose room, administration rooms, etc., etc., etc. We're very busy. We have somewhere around 400,000 admissions a year, so the pool is very, very well utilised. When it was first opened, all space and water heating was achieved with two 750 kilowatt lignite boilers. This was largely due to the availability of lignite and the available technology at the time. The facility requires fairly substantial heating from the heat plant, so we've got about 140,000 cubes of water, 140,000 cubes of air and around 2,500 cubes of water. That's equivalent to about 40 million double shots of coffee. So, you know, that's a fairly significant amount of water we're talking about. In 2008, the boilers were sort of nearing the end of their operational life, and Council began investigating options for replacement. And a quick sort of cursory investigation revealed that a like-for-like swap mightn't be the best option, as the existing setup didn't really allow for any growth. So there was also pressure on Council to investigate the possibility of using renewable fuel sources. You know, despite this, a feasibility study that we did in 2011 summarised that replacing the two old coal boilers with two new coal boilers was probably the best option. However, the study specifically examined the conversion of coal to wood fuel, yet still concluded that the best option was to use coal boilers that had the option of moving to wood fuel when a stable wood supply, you know, could be found. And I guess that was quite interesting because, you know, last year in 2013 there was 200,000 tonnes of wood chip exported from Bluff for the overseas market. And we're not a significantly large user, so for us, you know, there's a fairly stable sort of wood supply available. So in early November 2011, Council received a proposal from Living Energy to install a single wood chip boiler with a backup diesel boiler. And this went through many iterations and discussions, and the approval to proceed was granted by Council towards the end of November 2011. So a few people ask, you know, why did we do this when we're surrounded literally by coal and lignite? Well, the first thing is that there were some terrible rumours about what the ETS might do for our operational costs. And secondly, you know, Council, I think this is important, Council saw this as an opportunity to show some environmental leadership. None of our staff look like that, unfortunately. Thirdly, you know, moving to wood chip, and we only discovered this later, provided an actual and perceived improvement to health and safety. And this is due mainly to improved air quality from reduced carbon emissions, an improved handling environment for staff, and an almost non-existent waste product, and I'll get to that in just a moment. So really with one fell swoop, we sort of managed to vastly improve the health and safety for both our staff and our community. So this is all pretty wonderful, but there was some concern about cost. So on paper, initial estimates put the operational cost of using wood chip about $20,000 more per annum than coal or lignite. So Council spent some time debating the pros and cons of converting to wood chip with an obvious focus on cost. You know, but at the end of the day, there were some deciding factors. The first one being obviously the actual and perceived health impact. And I stress perceived because when we're burning wood chip, our users tell us, oh, the environment feels cleaner, even though inside the pool there's no real effect regardless of whether we use wood chip or coal. And I think that's quite an important factor. And of course, the leadership opportunity. You know, council would lose the chance to sort of practice what it preaches if it didn't in fact go ahead with this. So in late November 2011, council made the decision to go ahead with a proposed conversion or replacement of coal to wood chip. So we actually started the conversion the following year in June, and if I could just bullet point this. So the plan required that we had 2 coal boilers, remember, so we had to disassemble 1 coal boiler to make room for a backup diesel boiler. Then we installed the diesel boiler. Then we removed the 2nd coal boiler. Then we installed the wood chip boiler, and then we switched from the diesel back up to the wood chip boiler. And bearing in mind we did this in June, July, which is sort of getting on for the coldest months of the year, but we did this without any operational downtime, so it was really quite impressive. Of course, behind the scenes, there was a stack load of other work going on, modifying the existing coal bin for the wood chip, modifying pipework, modifying the boiler house, and installing new control systems. And the next few slides just show a few pictures of the actual change going ahead. So the first thing we did was remove the old boilers, and you can see us slicing this sucker up because we actually couldn't get the old boilers out the door. So we cut them into small pieces. This is a photo of the diesel backup boiler that had gone on. This is a relatively newer photo, and it shows, so we've installed this GSM modem here and a motorized actuator. So that automates a lot of the standby and backup process if the wood chip boiler goes down for whatever reason. The existing pipework was modified to make room for the diesel and wood chip boiler. And that is such a simple sentence to say, but let me assure you in reality, it was nothing like that at all. And so to get the new boiler in, we actually had to cut the door out and enlarge the opening and slide it in with a bit of Vaseline and whatnot. So the boiler actually went in 2 separate pieces. And in this photo, you can see the boiler getting mated together. There was some speculation that if there was a fire or something at this time, the photographer was probably toast, given that that was the only way in and out of the building. So fortunately that didn't happen. So that's 17 tonnes of new wood chip boiler in place and some of the external cladding going on in the picture on the right there. The photo on the left shows the cyclone being insulated with cladding going on, and the photo on the right shows the flue gas recirculation and high velocity cleaning ducting. And you know, curiously with this boiler, there's a lot of impressive engineering that's gone on with it, and you'll note 1, 2, 3, 4 inspection hatches just in that one section of piping there. There's a shot of the power and signalling cabling starting to go in, and I always like to point out just how clean the floor is. So this was a room that had 2 lignite boilers in it. It was constantly an inch deep in dust. The floor today is more or less still the same, so certainly not your typical boiler room. This photo, you can see the stoker auger for the chip. And this is the extract auger connected to the stoker auger on the bottom. And another example of the sort of cunning engineering that this thing has, there's a white bucket here with a red lid on it. That's full of water. A sensor in the stoker auger opens a valve which floods the auger with water if it detects a backburn. So that's another example of some of the impressive engineering in this thing. The first picture on the left there shows the main control cabinet. That's this thing up here. Next to the boiler, it contains the PLC, comms and all sorts of other weird bits and pieces. And the photo on the right is the front of the boiler with a cyclone on the right and the ash extract auger on the bottom there. So that ash extract auger lifts the ash out to a 240 litre wheelie bin, and that takes about a month to fill. And that ash that I'm holding in my hand there on the right hand side is what we're left over with. And it's basically potash. We actually send that to Council, Parks and Division, who mix it with, I guess, lawn clippings, and they make some fairly nice compost out of it. That's quite significant, I think, because I would never have done that with our lignite boilers, given its sort of toxicity and whatnot. Photo on the left is the boiler tubes, and the photo on the right is the combustion chamber, with a full-length reciprocating grate, which of course pulls the ash to the front and drops it down into the ash extract auger. And so the whole brains of the system are interacted on the front of the main control cabinet with a touchscreen. So this is quite an impressive bit of kit. The whole boiler can be controlled, set up, modified from the touchscreen on the outside of the MCC. It has a number of trend graphs that we can examine, and it also has a fault notification system that sends both emails and text messages to pre-programmed cell phone numbers via a small GSM modem that's also installed in the cabinet. This is another shot of the touchscreen on the outside of the MCC, and it shows the whole end-to-end system. So if a fault occurs in any of the delivery augers or in the burner itself or anywhere else, we get alerted to those things immediately. Actually, there was a comment made or a question asked about using hot air to dry wood chip and about problems with efficiencies. Well, the interesting thing here is if we look at the exhaust temperature, this is the exhaust temperature going out the stack, 132 degrees Celsius, and this is our combustion temperature, 679 degrees Celsius. So the boiler is very efficient at transferring that energy into heating the water and space heating for the pool. And that's the old lignite bin with a spring arm chip agitator. This thing here, that's the spring arm agitator there, and the auger that's taking the wood chip into the boiler inside the boiler room. So the total installation cost, and that's everything from bin modifications, control systems, the diesel boiler, et cetera, was about $650,000. It's a significant sum of money, but let's consider just for a moment some of the many benefits that we've had since we put this boiler in. So first of all, it's a renewable fuel source. It uses a renewable fuel source. And again, it's one thing to talk about sustainability, but another thing to actually go and do it. And I think this is a really good example of that. The new boiler is much cleaner and safer, a significantly improved work area for staff, and in fact, it's quite a pleasant place to be. On a cold winter's morning, you can shoot down there with a cup of coffee. It's quite a nice place to hang out. The new boiler, of course, is significantly more efficient than the previous coal boilers. So on average, we saw an efficiency of about 69% with the old boilers, but due to the engineering standard of our new boiler, that gets up to about 95%. So that's got several other significant implications. For example, reduced carbon emissions, which takes us closer to that almighty carbon neutrality, but it also makes maintenance on the outside of the building easier because we're not getting corrosive particulate landing on our paintwork that we have to wash off annually. As I mentioned before, the other benefits include a much safer working environment. Previously our maintenance staff were required daily to shift buckets of burning lignite embers into large skip bin, and we don't need to do that anymore. So we were dumping 1.5 skip bins of toxic coal ash a week, and now we're producing about 60 litres of potash a week, and that is significant. We've seen a huge reduction in maintenance man hours for the boiler, meaning they can now focus on other important tasks around the facility, and given the remote signalling and control systems, maintenance staff can now control the boiler from outside the facility using remote PCs or even their cell phones. And this is an example of the remote control systems, both on a PC and on a staff member's cell phone. And as I mentioned earlier, the control system sends text messages, emails, as well as having a number of its operations automated. For example, if the system detects that the wood chip burner faults, it will auto-magically engage the diesel boiler so that we don't compromise our water temperatures in the swimming pool. So the few outcomes I've discussed are not exhaustive, but it reasonably demonstrates our experiences to date. We have had some minor issues with fuel delivery, but that's more because we modified an existing lignite bin to take wood chip, and I think if we'd started from scratch with wood chip storage systems, we probably would have overcome those few issues. Regardless, some of the outcomes we've had since installing the new wood chip are we've increased one of the pool's temperature by 1 degree, and that might sound like a lot, but it's a significant improvement on the operation of the pool. We've significantly reduced our man hours. We're sending less waste to the landfill. There's less maintenance. There's less environmental impact. The new boiler is much safer to operate. There's reduced operational downtime given the backup boiler requires an alternate and independent fuel source. Whereas previously we had 2 lignite boilers, now we've got 2 separate boilers, one on wood chip and one on diesel. So we have very, very little operational downtime now. So safe to say, our expectations have been vastly exceeded. So I often get asked about the cost to run the wood chip boiler versus the old coal boilers, and indeed, the fuel costs are slightly more. However, I expect over time with the availability and subsequent competition in wood chip suppliers that the price will drop while the price of lignite and coal will increase. Interestingly, when we did our initial cost calculations for the wood chip boiler, we failed to take into consideration a couple of things. There are significantly less man hours spent operating the wood chip boiler. We've seen a reduction from 10 hours a week to 2 hours a week, and that's a significant saving for us in terms of labour. We were spending somewhere in the vicinity of $15,000 a year on the disposal of lignite waste, and that's now no longer required. There's significantly reduced maintenance, both of the boilers themselves and, as I mentioned previously, of the building and the cladding on the outside of the building. So we discovered that the costs must be looked at holistically to gain a real appreciation for the financial impact of moving to wood chip. In isolation, the costs do seem higher. However, in our example, the savings overall vastly offset the price margin on the wood chip. Overall, our bottom line has improved with moving to a wood chip boiler. And personally, I cannot speak highly enough of the positive experience and performance we've had with our boiler to date. Thank you. And if there are any questions, I will do my best to answer them.
Yes, Grant, do you pay for your fuel on quantity or gigajoule?
On, I believe it's quantity, and I think gigajoule, there we go. We would receive 30 cubes every 2 or 3 days, David?
Yeah, about 120 cube a week.
Yeah, yep. So obviously that changes with summer and winter.
Because of the burn size and stuff, it burns over between 12 and 33 cube at a time, just variation in the number of cubes and stuff. Who was the manufacturer of your boiler?
It's Binder out of Austria. Yeah. The Binder boiler is an 840 kilowatt boiler, and the diesel backup boiler is a 600 kilowatt boiler.
Were they imported?
Was it imported? Yes, it was.
Have you thought about doing the detailed cost benefit now? Do you really, it'd be really good to put those costs out there. And
Once we've got a couple of years of operation, just because in that first year we didn't really know what we were doing, to be honest. But now that we've had nearly 2 years of good, steady operation, we probably can now start to look at doing a detailed analysis.
validation.
Yeah, and we tried different fuels and whatnot. We eventually came back to pine. So we're probably now in a position where we could do a detailed analysis. Absolutely.
We did quite a bit of trialling that first year on different fuels like seed and plus moisture content. So we've sat around we're at 20%, which is optimum for the boiler.
Is that 20%, there was the comment before about, supplying for sort of 35% and that was air dried, so are you actually heating that chip at all to get down to the 20%? How do you achieve that?
And Jameson talked about it shortly, but it's out of our manufacturing plant, so it's common dry product that we're mixing with wheat, salt and chip to get to the 20%.
What capacity does your boiler run at?
That's a very good question. It's never higher, I would say, than 60 or 70%, and that's worst case scenario. And in fact, during the summer months, I think can just sort of tick along.
50%?
Well, yeah, almost not doing anything.
So the minimum turn down is about 25%.
It'll turn down to 25, or it'll run at 25?
Is it 50? Okay. Yeah. It'll run at that.
At what?
At the sort of
15% of...
It'll run at 15% of nameplate.
Basically, water is not a superb heat sink, but in the facility in summer, it becomes a great heat sink because the way Splash Palace is designed, we can't actually cool the building, we can only heat it up. Even when we're trying to cool it, it still heats up. So in the middle of summer, when the outside ambient air temperature is 27 degrees, and we're only heating the main pool to 27, 28 degrees, the boiler can just trundle along doing very little. Very good. Thank you. All the best to the rest of your conference. Thank you.